Okay, so my name is Dermot O'Connor, and you've obviously received my email because I've noticed that a lot of you have uh, um, enrolled on the Slack channel, so that's good. So I'll just get going if that's okay. I did explain that there's a change in the module name from last year. Now, it has no material difference really from your perspective. I'm covering the exact same material that I covered with last year's class, just in case you knew anybody in fourth year last year. So to an extent, it's cosmetic, although, as I mentioned in the email, I think the name now, Cloud App Development, is more representative of what I actually do in the module. So that aside, I know that the web app dev module, if you can remember it from third year, the people that delivered that module used this website approach towards presenting or publishing the material. So I'm actually using the same. I don't use Moodle at all except for assignment submissions. So all of the slides and all of the labs will be published on this website, and I've given you the URL for it. So just bookmark it, I guess. So this will grow as we move our way through the semester. These lectures are going to be recorded, and I'll publish the recordings behind this card here. So obviously at the moment there's nothing there. And again, that will grow as we work our way through. Um, I think I'll just start with a brief overview of the module, very brief in fact, and then we'll get into the meat of the first topic. So I'm just going to flick through these slides here, and I'll bring them up in PowerPoint in my case. Just before I begin, I suppose, in case there are any initial housekeeping issues that I need to be aware of, is there anything that anybody wants to ask me about this module so far? By the way, I'm happy for people to just butt in and ask questions as we work our way through this stuff rather than typing them into chat in Zoom. I just don't tend to keep an eye on what's happening on chat. So, don't be shy. Feel free to just interrupt me at any stage. So the logo on this slide is kind of a giveaway in that it's all AWS stuff that I will be using as a basis for teaching this material. And I just noticed before I started today's lecture that I actually never updated this slide in that I'm using the old module name here instead of the new one. So uh, me bad, as they say. And all I'm trying to get across here is that, in terms of how this module is linked to what you already know, clearly there's a strong link with the DevOps module that you had in third year, um, because that was also very much AWS based. We won't be using any of the services that you already are familiar with. I suspect you were doing a lot of EC2 stuff in this module in third year. We won't be using EC2 at all, although I will actually use it in the very first lab. That's really just because to give you a link back to some stuff that you already know. But for the entire duration of this module, bar the first lab, we'll be using a compute service called Lambda, amongst other services. So there's a strong link between this module. The reason I've included the web app dev module also in third year, and I've just kind of given a thin arrow here and a thick arrow here to indicate that there's a much stronger link here. The only link back to web app dev is that if you remember from that module, he developed a front end using the React framework, and he developed a back end using using Node. And you might remember it was a RESTful backend. That was its kind of architecture style. We'll be implementing RESTful backends as well, but we'll be deploying it onto the AWS cloud and using these Lambda services, plus some other services like API Gateway, DynamoDB. So in that sense, there's a link to this web app dev module, but from a technology point of view, it's a different technology stack that we'll be using here. So that's kind of a context in a way. On this slide, on the first bullet point, I just extracted the very first sentence, I think, from the module specification. Module specifications are things that we have to write for our external examiners. Probably most students don't ever go near them, but it's still worthwhile maybe paying attention to the module specification. So that's what I went back to, and I extracted this very first sentence. And it is, as it should be, a reflection of what this module is all about. And this bullet point here was kind of written when the module was called Distributed Systems, but it's just as apt now that it's been renamed. So that kind of reinforces the point I made at the beginning that there's no material difference from your point of view. But the sentence talks about comprehending the architecture of distributed, and distributed today really means it's cloud-based. Understanding the architecture of cloud-based service-orientated, that kind of relates to this idea of microservices. I wouldn't worry about that aspect of it. But the architecture of cloud-based applications. Now, but in particular, we're interested in the development and deployment. And so by including development and deployment in this sentence, I'm trying to get across the idea that it's very practical based. We're not looking at architecture purely from a theoretical point of view, from a visual point of view. We actually want to be able to develop cloud-based applications, and also there's a strong emphasis on the deployment of them. It's no good just running them locally, and it's actually quite difficult to run them locally if we intend on using them on AWS. So the whole deployment process is very important as well. And you will see that from very early on and right throughout this module. Here then I'm just kind of breaking down more in a little bit more detail some of the topics that we're going to come across. So one of the early topics, bar the first maybe two lectures, we'll then talk about infrastructure as code. Now I know that is a concept that you're familiar with from the DevOps module. Can anybody remember? Can anybody remember what part of the AWS cloud platform deals with this whole area of infrastructure as code? Can anybody remember the name of the service that deals with this infrastructure as code idea from the AWS platform perspective? Like it's not EC2, that's just a virtual machine service.
CloudFormation, isn't it?
Say it again.
It's CloudFormation.
Yeah, that's the one. Yeah. Now, we won't be using CloudFormation directly. We'll be using, I suppose you could call it maybe an abstraction on top of CloudFormation. And the reason we're going to use an abstraction is because CloudFormation, as you might remember from third year, you have to write this YAML code or JSON, one or the other, and it can be quite verbose and error prone. And there are easier ways of achieving the same result using effectively ordinary programming languages. So we'll be writing actual code. You could hardly call YAML or JSON code, but we'll write actual code, and then when we compile that code, it will be transformed into CloudFormation YAML, which is all CloudFormation understands. So that will be a part of it. Serverless is one of the architectures that we're going to look at. We've probably heard of serverless somewhere along the lines, but we'll actually get to implement and deploy, admittedly, small applications. Because up here I talk about constrained set of requirements. So we can't obviously be developing and deploying large applications. We just don't have the time for that. So we will be developing quite small applications, but that's fine. It's just a proof of concept we want to get across. But the application, we'll see around about the first maybe half of the module will be all about developing and deploying applications that follow this serverless architecture. So we'll talk about serverless in general, and then we'll get into the meat of how we actually achieve it. When we ever talk about deploying anything to the cloud, scalability is always an issue. So I'll be constantly mentioning scalability issues as we work our way through this module. We just need to be aware of it, I suppose. We won't be necessarily fine-tuning our application from a scalability point of view, but I'll just be highlighting many kind of aspects of the AWS services, the serverless services that honor the notion of scalability and guarantee, to a degree anyway, scalability in your application architecture. The second type of architecture that we look at, and again, you may have heard of this as well in passing, is what's referred to as an event-driven architecture, which is kind of the opposite of your standard request response type communication protocol that you would be very familiar with, certainly from the web app dev module. But this kind of request response model is fine, but it's not necessarily scalable, to go back to that term. And so an alternative is this event-driven approach. And typically you would have a mixture of the event-driven approach and the more traditional request response style within your application's architecture. So we look at the AWS services that follow this event-driven pattern as well. That will be towards the latter end of the module. Now, oddly enough, you might think anyway, we're going to use TypeScript as the language for developing our serverless architecture. We're going to use TypeScript as our way of implementing infrastructure as code, which a lot of people initially kind of are surprised by. But that's what we're going to do. We're going to be implementing our serverless architectures and our event-driven architectures all through TypeScript. Really, we could use pretty much any language. Most people would think Python might be the language you would use when you're talk about any cloud-based, AWS cloud-based applications, but AWS supports multiple languages, all the way from Python, TypeScript, all the way up to Rust, if you've heard of Rust. So I've just plumped for TypeScript really because about 3 years ago, this is my third time teaching this module. So 3 years ago, I was just interested in learning the TypeScript language. And so I said I'd use it within this module as a motivation to learn the language, I guess. But you will get a lot of stuff online, actually, on the web. When you start Googling for articles around this area of cloud app development and infrastructure as code and AWS, you'll get a lot of stuff that is actually using TypeScript to illustrate whatever the article is focused on. Right. Prerequisites, there's no surprises here, really. You pretty much have everything. You should have everything already on your laptops. So just to quickly go down through them, you need to have the AWS CLI installed on your machine, which you should really have from that DevOps module that you've studied in third year. You need to have Node.js on your local machines which you would have from the web app dev module in third year. VS Code is what I use. I don't really care what code editor you use, but I use VS Code, and I'm sure that's the one you used actually in web app dev as well. You need to have Git installed locally. Probably most laptops come with Git pre-installed already, but if not, you need to install it. I thought I actually had a URL there that told you where to go to install it, but just do a Google search and you get it the first hit. You need a GitHub account, that's okay. You need to have knowledge of JavaScript, that's okay as well. So there's nothing new really here. Oh, sorry. The very first point here, actually. I don't know why I skipped over it. Clearly, you will need an account on the AWS platform, but I'm emphasizing here that you will actually need to sign up with your own account. You'll have to create your own personal account. I know in the DevOps module in third year, he used accounts that were provided by, what was that service that she used? I'm trying to think of it. Can anybody help me? I know Richard essentially kind of created accounts for ye on AWS and ye used those, but those accounts that you used in the DevOps module, those AWS accounts, they won't work for this module because we need more privileges than those accounts grant to you. Okay, so that's why you actually have to go away and create your own personal AWS account. I don't care whether you use your with email or your own personal email as part of the registration process. You will need to provide a credit card, but we will not incur, or we will incur very, very little expense in this module. I would say max maybe €10 for the entire module, €15 max for the entire module. But you do need to create your own account on AWS. Okay, clearly you need to be familiar with the AWS Management Console. You need to be comfortable navigating around that because I use it a lot throughout this module, and I'm assuming you're already okay with that. What else? 2 lectures per week, all of them online, 2 labs per week per student as well. Now I know there is a room allocated for the labs. I will try to attend them. There might be an issue next week. The labs will definitely run. There might be an issue with me attending, which has nothing got to do with E really. It's got to do with the fact that I'm teaching other modules that require network access, and the college Wi-Fi is not sufficient. So I'll actually have to deliver those other lectures from home effectively. This is all stuff you don't need to know now, but maybe that might be resolved after a week or two if the college Wi-Fi that's set to Red or Eduroam Wi-Fi networks are slightly more open up so that I can use ports that are currently not available to me. That's a bit of a waffle now, really, but for now, for next week, it looks like I may not be able to attend the labs, but I'll communicate with you over via Slack in the meantime if that changes. Assessment, 100% CA. You will be submitting some of the labs work that you do. Okay. I think there may be 2 labs, maybe 3 of the labs. There'll be a lab every week. Maybe 3 of the labs I will get you to hand up. And really, it's the labs, as you will see, are very prescriptive. There may be an exercise here and there, but the majority of them is a case of just reading through them, cutting and pasting code. Obviously, not just blindly cutting and pasting. You need to be learning as you're doing that. But it's quite easy to get the most of the 10% from the lab submissions. There will be only one assignment. We're at 45%. That's actually going to be on the serverless side. And there will be what I'm calling a lab-based exam, either on week 12 or week 13. It's a long way away, so obviously can't schedule it this early. And that lab-based exam will also be worth 45%. And it'll be about maybe a 90-minute-ish duration, but there's no point in talking about that at this early stage. So that's the breakdown of the assessment. Just pause in case there are any questions that come to mind so far. No. This is just for completeness. So you already have the URL of the website. And I don't know, when I checked earlier in the week, there was only, I think, one student registered on the module on Moodle. Have the rest of you got access to the module on Moodle?
So from what I know is that everyone was on placement. A lot of people were on placement last semester. So the registration is done till the 18th.
Oh, yeah.
And people on placement last semester are not able to register till the 18th. So
okay, yeah, we don't really need to get access to Moodle anyway, as it turns out. Well, just contradict myself now. The first lab that we will work on, which will really span over next week and maybe into the third week, that lab I do require you to submit, but that's about 2 weeks away minimum. So hopefully by then everybody will have a Moodle access, and if not, just get in touch with me and we'll sort it out. But other than that, then we won't be using Moodle again until about week 7 or 8, I think. Okay, what's this slide about? Well, this is just a screenshot from the website from last year, I think. So it just kind of gives you an idea of the topics that we're going to, and it's kind of, we work it through it from left to right. So we'll start off by looking at I'll just give a fairly quick run through the basics of the TypeScript language, because that's what we're going to be using, as I've already said. Some of you may have used TypeScript already, but look, languages are languages, so there shouldn't be too many barriers there. Then we'll talk about infrastructure as code. Then we'll talk about serverless, then event-driven architectures. And if we have time, we'll talk about full stack. Essentially, what full stack will allow us to do is to pull all of this kind of stuff together. And the rest is okay. I'll publish the assignments or the assignment on this website as well. And this is where the lecture recordings would be. Okay, so back to the website. So this is the first topic. I couldn't get an image that said lab work, so and I could get his homework, which is very kind of primary schoolish, but anyway. So any of these cards, as we call them, that has homework behind it, that's effectively a lab. And if I just quickly go into it, these are the style of labs, as I said, that you would have come across in the web app dev module. And again, they're very prescriptive. So you really, you should be able to walk through the lab without me, holding hands with you, which is why my attendance at the lab, even though I definitely obviously want to meet you face to face, but my attendance at the lab is not critical. And anytime you have a problem working on a lab, feel free to put a message up on Slack, either in the general channel on Slack, just in case other people have come across the same problem and provide a solution, or you can send me a direct message on Slack. You can put messages up anytime. Clearly, I'll answer them immediately if it's during lab hours. If it's not during lab hours, I will answer them as well, but you may not get an immediate answer. Okay, let's not worry about the lab for now anyway. And I want to work my way through these slides here. This URL here is a GitHub repo that you can clone, and it will contain the code that you see me discussing during this lecture and probably next week's lecture as well. So that's available to you. You can clone that later on. You probably know something about TypeScript already, but it is an open source language developed by Microsoft. Probably haven't heard of this guy, Anders Hellsberg, I think is how you pronounce it. So probably not a name that I knew either, but when you look him up, he's quite a noteworthy character. He's developed a number of languages, C Sharp, Turbo, Pascal. He's also the designer and creator of the TypeScript language, a Microsoft employee. So he has a fairly checkered history. But the language itself, TypeScript, um, it's what we often say is that it's a superset of JavaScript, which kind of means all JavaScript is implicitly TypeScript. But what TypeScript does is it adds a type safety essentially to the JavaScript language. The JavaScript language is fantastic, but it is a dynamically typed language. What does that mean? It means that simply, if you declare a variable, on one line you can assign one type of value to that variable, but on the very next line you can assign a completely different type to that variable. That's what dynamic typing means. That can be very powerful, but it also can be very error prone, and it leads to lots of problems when it comes to debugging your code. And in very simple terms, that's the motivation behind TypeScript, to layer a type system on top of JavaScript. TypeScript is actually only a compile time language. It's not a runtime language. You cannot execute TypeScript. What you've got to do is compile it into JavaScript and then run your JavaScript code. At the point that people even that know quite a lot about TypeScript don't grasp. It's only a compile time language. It was based, or this guy Hallsberg, he based it on ECMAScript version 4 and 6. What is ECMAScript? See that thing there, ECMAScript. ECMAScript is the specification for it's the specification for a language. The only implementation of that specification is JavaScript. I don't want to get bogged down in this kind of stuff now, but we just really want to look at the language itself. But so the ECMAScript is the specification essentially for the JavaScript language, and the JavaScript language has been around since about the 1990s, I think. So it's obviously gone through a number of iterations. And so what happens is the ECMA organization, ECMA stands for European Computer Manufacturers Association, they publish an update to the ECMAScript specification. Well, now it's almost yearly, but there were kind of larger gaps between the specifications in the earlier periods. But either way, what Hallsberg did was he took version 4 of the ECMAScript specification, which I'm saying there was around 2000, and he also took version 6, which is around 2015. He brought those together, and that formed the basis for essentially what he added to JavaScript, the kind of type system, as I said. Okay, that's just, by the way, just kind of nice to know, but pretty useless beyond that. A superset of JavaScript, that's right, that's fine. But it's, oh yeah, okay. So, you could essentially take any JavaScript file, rename it to a .ts, which is the suffix for the default suffix for TypeScript files, and it now becomes a TypeScript. Now, plain old JavaScript it would probably be regarded as poor TypeScript. It's still TypeScript, but it's badly written TypeScript, mainly because it hasn't utilized the typing system that's available in TypeScript, as we'll see. And as I said, TypeScript is only compile time. These are kind of interesting comments made by, again, some luminaries in this whole web space. Anybody know who Bernard Ike is? I'm asking too many questions maybe, but Bernard Ike? Bernard Ike is still alive, the creator of the JavaScript language. Again, a fairly prolific guy in this whole space. But his comment was that the one thing TypeScript got right was type inferencing, and I'll talk about type inferencing in a while. If we didn't have type inferencing, it's arguable that maybe TypeScript wouldn't have caught on as much as it has. And there's another interesting comment from another luminary in this space as well about the TypeScript language. TypeScript was really written because, if you're only developing a small application, and you don't know TypeScript, it's kind of questionable as to whether you really should switch to TypeScript. You could probably just stick with JavaScript if it's a web-based application. But if you're developing a very large application, that's where TypeScript really shines, mainly because it catches any silly errors that you might make in your JavaScript code. It will catch them. TypeScript will catch them at compile time. Okay, let's move on. The GitHub do an analysis of all of their repos every year, and they publish, amongst other things, they publish the most popular languages on the GitHub platform. And this is the result of the analysis from 2024, 2025, when I don't think will be available until the end of the year. But what it's showing us is that TypeScript is the third most popular language. For a number of years, as you can see from the diagram itself, for a number of years, JavaScript was the most used language on GitHub. Now, Python has actually jumped to number one, mainly as a result of AI. That's only happened within the last 12 months. It was always around position 2 or 3. But the TypeScript language, okay, it's position 3. But if you think about it, Python certainly, and JavaScript, and many of these other languages here, they have been around for a number of decades, whereas TypeScript, which I think we said was around 2010, 2012, was when Halsberg created it. So it's a much younger language, but it has already rocketed up to third position in terms of its popularity. And that is really because of the fact that it's well-written JavaScript effectively. So any software house now that would have been developing JavaScript applications, they most certainly have switched over to TypeScript because of the advantages of the language. So it's good to have it on your CV, I guess is the point. TypeScript files, by default, the extension is .ts. There are also files with the .d.ts extension, and these are referred to as declaration files. They're like header files in C. If you've come across header files, you should anyway put all of your custom type declarations into these .d.ts files, and we'll see what I mean by custom type declarations. You can effectively define your own data types in the TypeScript language on top of the data types that come with the language. Now, you can put your own data types into a .ts file. It won't complain, but it's better practice to put them into .d.ts files. Also, where these .d.ts files, where you see them used is, you see there are tons and tons of really, really good JavaScript libraries out there. Now, clearly, we'd like to avail of those JavaScript libraries in our TypeScript projects or applications. But the JavaScript libraries don't have any, when they were written anyway, they didn't have any type uh, type definitions associated with them. But what the developers of these JavaScript libraries have done is they have added in these declaration files, these TypeScript declaration files into their JavaScript libraries so that we can now use them and avail of the benefits of the type system in our TypeScript projects. And we'll see that maybe a little bit when we work through this, because we'll obviously be using an awful lot of third-party JavaScript libraries, but it would almost seem like these JavaScript libraries are actually TypeScript, but they're not. And the only way they seem to be TypeScript is because the authors have added in these declarations, these TypeScript declaration files into the JavaScript libraries. It's also very beneficial for our tooling. Okay, any language has its primitive types, and TypeScript is no different. And the primitive types in TypeScript are the same as the primitive types in pretty much any language you've ever come across. So we've got a number type built into the language, a string type, a Boolean type, a string type, and we've got null, and we've got the undefined type. Undefined comes from JavaScript. If you remember, in JavaScript, if you declare a variable and you do not initialize it, then the default value stroke type for that variable is undefined. Like if you did a console log of that variable, even though you haven't assigned any value to it, then the console log would just output undefined. And in fact, it's this undefined, it's both a value and a type in JavaScript now. It's really the source of so many problems in the language. So anyway, it's still there in TypeScript because TypeScript is built on top of JavaScript. But we can catch it much earlier in our development lifecycle rather than coming across it when we actually run our applications. Null, I don't think is null available maybe null is available in JavaScript as well. Didn't check that actually, but you've come across null before anyway. So there is a kind of in fact, it definitely is null is available in JavaScript. There's a kind of technical difference between these two. Null is something that you explicitly assign to a variable when you're not assigning a meaningful value, if you like, but you have made an assignment, you have assigned it to a variable. So that variable is no longer kind of undefined. It actually has a value. Undefined is badly named. Undefined suggests that a variable hasn't been defined or declared, but what it actually means is the value has not been initialized. And then, in JavaScript, as you know, there are primitive types, which are really the same as these here. And in JavaScript, everything else is an object. Okay. And that still applies in TypeScript, but the TypeScript has added some more types, as we'll see, other than just the kind of bog standard object. TypeScript has classes and modules and interfaces, but in fact, they're in TypeScript because they've been made available, they've been added to the JavaScript language. If I just go back for a second to this slide here, where I talked about ECMAScript. ECMAScript 6 around 2015 was when classes were added to the JavaScript language. Classes are not native to JavaScript, unlike a language like Java, where they are native. They're not in JavaScript. They actually have to be converted back to plain old objects behind the scenes. So the fact that TypeScript has classes, has nothing really got to do with, has more to do with the evolution of the JavaScript language. What is nice in TypeScript is it supports typed arrays, as you'll see. Now, there is this kind of odd named type in TypeScript called the AnyType. You can actually have a variable and you can declare it as being of the AnyType, which means, you know, it could be any of these. It's something that to be avoided, but it's a fallback if you can't avoid it. But you should try and avoid ever having a variable which would be classified as the AnyType in your code. All types are subtypes. So any type that you add to the language, as well as the additional types over and above the primitive types, those additional types are all kind of subordinate to the AnyType. On the next slide here, I wouldn't worry too much about it now, but this is the built-in type hierarchy in the TypeScript language, and almost at the very top of the hierarchy is the AnyType. There's this odd one as well called the unknown type, which we'll just ignore, right? So at the top of the type system in TypeScript, at the top of its type hierarchy, if you like, is the AnyType. And then you can see the primitives are immediately below that, the ones we talked about, Boolean number, big int, okay, we didn't talk about string. And then over here we have object, and then we've got some subordinates, so arrays, like that's arrays not available in JavaScript at all. It is in TypeScript. Function is not available in JavaScript, the actual type function. I know we can write functions, but behind the scenes in JavaScript, functions are actually implemented as objects. I'm sure you've never seen that, but that's what's actually happening. And then there are a few more odds and ends down here, which we needn't worry about. Now, when we define our own types, which we do, we're kind of essentially adding it on to kind of here. You know, we're adding on our own type, which will be subordinate to the object type. That's just by the way. Okay. So there's this odd one up here. Again, as I said, don't worry too much about this hierarchy. After a couple of weeks of writing TypeScript, in a sense, it won't be relevant, but just including it for completeness. Let's talk a little bit about the syntax of the language. So the very first thing that you learn about TypeScript is what are called type annotations. Type annotations is the syntax that you use to tell the reader of your code and the TypeScript compiler what is the type of a particular variable. And the way you do it is by writing it as using this postfix syntax. So I'm saying here, what is type annotations? It's a lightweight way to show the intent, the intended contract of a variable. In other words, how do you intend to use that variable throughout your code? You can also use it with functions, as we'll see in a while. So let's switch over to VS Code, because it's all talk up to now. Let's look at some actual TypeScript code. So this is the project that you can access from my GitHub account, and I mentioned the URL there at the beginning. TypeScript projects are really node projects. So you can see down here, there's a package.json. Where is it? Oh yeah, there, package.json. So whenever you see package.json in a project, that tells you need to run npm install. So this is really built on top of Node. And let's look at some of the basic syntax. I've got an index.ts. And straight away here we're declaring a variable using the let keyword from JavaScript. The variable name is this, and here's our postfix syntax. So we're stating that the type of this variable is string. And that's consistent with what we're assigning to the variable. We're assigning a string value to the variable. If we try to assign a different value, like a numeric value or an object, then let's actually do that. Let's take this out and go 12. The squiggle line in VS Code anyway tells us that there is essentially it's telling us that the compiler, the TypeScript compiler, is reporting an error. Now, when you're using VS Code as your editor and you're writing TypeScript code, always keep the problems tab down here. Always keep that open, or keep an eye on it at least, because that's where it's going to report any TypeScript errors. And it's reporting these before you run your code. So you're not discovering silly errors after you've ran it. You're discovering it at development time, really. And the error is kind of telling us, look, you can't assign a number to a variable that's declared as string. Essentially, it's what it's saying here. Okay, so let's undo that. Anywhere else, if we want to assign a different value to our variable, it still has to be. So if I take this again and I go, I definitely want to assign the value 12 to it. No, it's just not allowing me to do that. Now, the point is that in JavaScript, if this was JavaScript, well, obviously we wouldn't have the postfix syntax here, but in JavaScript, this is perfectly legal. And that is the root of many, many problems in the JavaScript language, as I've kind of already mentioned. So from a syntax point of view, it's this postfix syntax that we use to declare a variable's type. And I've just got some other examples, number, Boolean, I think, as well. Let's just pull that down. And, you know, the compiler is always monitoring what you're doing with variables. So I've got a number here, and that's fine. I'm doing the +1 operation on it. That makes sense from a number point of view. What am I doing there? Oh yeah, well, that's just the same point again. Like if I uncomment that code, you know, I'm trying to assign a string to a variable that has been declared as number, doesn't like it for the same reason. Similarly, if we take this line here, what are we trying to do? Trying to invoke the toUpperCase method on this variable, and as we know, toUpperCase is only something that's it's a property, if you like, or a method of string. You can't invoke it on number, and you know the compiler is complaining. And again, if you read the error down here, it's telling you why it's an invalid statement. And again, without overemphasizing it, you're discovering all of these mistakes in your code at compile time, or really at kind of at editing stage, because the TypeScript compiler is constantly monitoring what's going on in your code as you type it. In JavaScript, you don't discover these kind of mistakes that you're making until runtime. Okay. Just by the way, regex there, as well as the primitive types, the TypeScript language also has some additional useful built-in types. So for example, there's a regex type, which stands for regular expression. And you can just look at that code yourselves. So I'm sure you're familiar with regular expressions from somewhere along the lines in your previous studies. Typed arrays. Here's the syntax for declaring an array where the elements in the array are all of the same type, which they must be in JavaScript, you can have an array and you can have a mixture of different types within that array. That's legal from JavaScript's point of view. It's probably not good design, but it's accepted from the language's point of view. However, in TypeScript, that's not allowed. So here's the syntax for declaring an array. So it's this kind of subscript syntax, and what type then are the elements in the array. And the assignment statement is consistent with what you're declaring over here. And it will only allow you to push new elements onto this array, provided the element is of type number. If you try to push another type of variable, it's going to complain once it sees that in your code. Let's forget about this for a second. Let's switch back to the code. Typed arrays, that's okay. This is an alternative syntax that you can use. Here, what I'm doing is I'm declaring an array of strings. So the array keyword with the angle brackets, and then inside the angle brackets is the type for the elements of the array. So that really is equivalent. It's kind of a longhand for this here. We would nearly always use the shorthand, obviously, because it's less physical typing. We'll see this angle brackets syntax later on when we talk about generics, which is kind of a bigger topic. So either or syntax works. And what am I trying to do here? Let's just uncomment that line. Oh yeah, this is the point I was making. So my nums is an array of numbers, but here I'm trying to push a string onto that array, and the compiler is again complaining. And if you can see the error down here, telling me it's illegal for obvious reasons. Okay, back to the slides. We'll come on to it in a little bit more detail, but this type annotation syntax, you also use it with functions. A function has a signature. A signature is the parameters that are passed to the function and its return value. So from a type annotation point of view, you need to declare what are the types of the parameters of your function and what is the return type. And that's what's going on here. So I've got a function called add numbers. It looks like it takes two parameters. I'm saying both of them are of type number. And this bit over here is declaring the return type for this particular function. And if you look at the returns, well, I don't have a return statement, but essentially how does the compiler check to make sure that the body of the function is consistent with what you're stating here? It essentially looks at the return statement or statements in the function, and it makes sure that the value that is being returned is of the appropriate type. Otherwise, it'll get a compilation error. But from a syntax point of view, using type annotations on your function signatures is something that we do a lot as well. We will come back to functions in a bit more detail. Classes are available in TypeScript, as I've already said, because they are available in JavaScript. And I'm showing you the syntax for classes here on the right. I'm not going to talk my way through this because it's very similar to Java, really, from a syntax point of view. So you can study that yourselves. I don't need to explain it. And the only point, I suppose, is that only single parent inheritance is supported in TypeScript. You can't have multiple parent inheritance. TypeScript also supports the notion of interfaces. And again, I'm assuming people are familiar with interfaces from Java. And they have the same meaning in TypeScript. And again, on the right, I'm showing you the syntax for coding up interfaces. And down at the bottom here, I'm saying that it supports multiple interfaces. So a class can implement many interfaces. So we can skip through those really. Now, unfortunately, I think there's also this, there is this concept in TypeScript called interface data types. It's a pity that they use interface in this name, because some people confuse it with the more traditional meaning of interfaces, which we had on the previous screen. But interface data types, what that allows you to do essentially is to define your own object data structure types, yeah, or IDT for short. So an interface data type tells the TypeScript compiler about the shape of a data object. So from a syntax point of view, this is what it looks like. And, that syntax there looks very similar to, if I just go back to the previous, it looks similar to this syntax here. And it is. But what we're doing here is we're describing the shape or the structure of a data object. And in this simple example, I'm declaring, essentially now what I'm doing here is I'm declaring my own custom data type. The name I've given my custom data type is person, and its shape is, it has two properties, one called first, one called last, and they both happen to be of type string. And here then I'm declaring an actual variable whose type is person. And here's the actual value that I'm assigning to that variable. And the structure of the value, the shape of the object, is consistent with the shape of the interface data type that I've declared here. Yeah, that's pretty straightforward as well, I hope. Let me see if there's anything interesting in the code. Same one as the one we had. It's all right. That's okay as well. And what's nice again, okay, there are two properties here, but if there were many properties, and rather than the developer having to remember the names of all the properties, the compiler will help you out. So for example, if I just get rid of this for the moment. Now, there's a compilation error at the moment, because if you look down here, it's essentially telling you that you've got an object, you've got a variable here whose type is person, but it doesn't have all the properties that a person object needs to have. That's just kind of the simple explanation of what the error is stating down here. But to get back to the compiler kind of helping us, if I just start typing, it's telling me here, it's helping me here, it's telling me that maybe the property that you want to add is called last. And so really, obviously, all it's doing is it's looking at the structure of person, and it's helping me out in terms of what other properties I need to add on to this object. So I go, yep, that's it, and I give it its value. And that can be useful, as I said, when you've got quite complex data structures. Let's just undo all of that. Now, unlike JavaScript, what you cannot do is dynamically add properties to this variable. So my variable is called me. In JavaScript, as you know, you can add new properties to your object at runtime, and there's no complaint from the runtime. Really, it won't cause any problems. But TypeScript doesn't allow you to do that. So, for example, if where do I have it? Oh yeah, if we try and do this, right? If I try and add an address property to me, again, I get my squiggle line, and down here it's telling me address is not a valid property of person. So you're constrained in that sense, and that's classic kind of dynamic typing versus static typing. Static typing, you're slightly more constrained, and you have to think about the various structures up front, if you like. So that's not allowed. And what are we doing down here? Oh yeah, so just to give you some other slightly more elaborate examples. So I've got an interface data type called CEO student. It has these properties, that's okay. Though look at this property here, right? One of the properties is an array of strings, because obviously data structures are not always as linear as our person object earlier on. They can be more complex in terms of having nested objects and nested arrays within objects and all that kind of stuff. So yeah, you're not constrained from that point of view by TypeScript. And here's one simple example of it. I can have a property that's an array of things and happens to be an array of strings in this case. You could even have an array of persons if you wanted to, and so on. What's this? So this is an instance of CEO students. That looks fine. I've got a oh yeah, a semester result interface data type. And what's useful about that? Okay, well, that looks pretty simple. Then I've got a student exam profile, which has, what does it have? Okay, it has a property of type person. It has an array of one of my custom data types. Essentially, that's another word for interface data types. It's your own custom data types. So, it's quite powerful from that point of view, these interface data types. I won't say it's a drawback, but let's call it an advantage. What it requires you to do is to think about the data structures that are going to be useful in your application, and you design those upfront ideally, although maybe in real life you add them as you discover what's going on here in brief. And you can go back and look at the syntax of it yourselves. Okay, let's pick it up from here. So that's interface data types. Now, there's also something called type aliases, and they overlap with interface data types, but they also have a number of other aspects to them, which IDTs don't. And we'll come back to type aliases again later on. But for now, kind of as its name suggests, a type alias, essentially it also allows you to define your own custom types, and it allows you, but it's much more flexible than IDTs. Let's put it like that. And I'm showing you some examples here of where we can use this type alias syntax. So from a syntax point of view, when you see the word type at the beginning, that means you're using this type aliasing. And the way you interpret this line here, for example, is I'm defining a new custom type. So that's kind of over what I said in relation to interface data types. Interface data types allow you to define your own custom types, while type aliases do the same. But here, what I'm doing is I'm defining a new custom type called alphanumeric, and I'm saying it could either be a string or a number. So here I'm declaring a variable whose type is alphanumeric, and I'm assigning the value 10, which is a number. So from a compiler perspective, the value that I'm assigning to this variable is fine, because I've told it that this type here could either be a number or a string. In this line here, same idea. I'm assigning it a string in this case, but the compiler doesn't complain. And there will be cases when a variable could have more than one type of value assigned to it, which is why we have type aliases. And you can have as many R's as you want to, if that makes sense. So that's one use case for type aliases. Here's another one called literal types. So I am declaring a type here, and the name I've given my type is pet category. And I'm saying essentially the way you interpret this, I'm saying any variable whose type is pet category, the only values that you can assign to it are cat or dog or goldfish. You cannot assign any other value. So it's very constrained. But again, this feature actually can be useful. It may seem like an odd feature, but it can be useful. So just sticking with the example, so I'm now declaring a variable here. Its type is pet category, and I'm assigning it the value, which is a string called dog, and that's one of the legal values that I've mentioned up here. The third use case for type aliases, and there are other use cases which we'll see later on. The third use case is really the exact same as interface data types, which is why I said at the beginning that type aliases and interface data types, they do overlap, which kind of begs the question, why did the designers allow that? And I've never seen a sensible explanation of it, so we'll just have to run with it. But if you look at what I'm doing here, what am I doing? I'm declaring a type for a start anyway. The name I've given this type is point, and I'm here describing a data structure. That's exactly what interface data types was doing. Okay, so anyway, this particular data structure looks like it has two properties called x and y, and they're both of type number. And it doesn't matter whether I use type aliases or interface data types to define data structures like this. It's pretty much a matter of your own preference. Some people like to use type aliases and forget about interface data types. Others mix and match. But you can't do this kind of stuff here with interface data types. So that's an introduction to this idea of type aliases. And the code has probably examples that are similar to the slides, but let's just look. By the way, actually, one thing I haven't shown you, because I've got console logs scattered throughout this code here, right from the very beginning, various console logs. So it begs the question, how do I actually run this file? And so let's do that. Now the assumption is you have ran npm install first. And so to run a TypeScript file, there are a couple of ways, but one way is npx. I'll explain what's going on here now after I've just ran it first. I don't have to specify index.ts. If you don't specify an actual file name, then it defaults to index.ts. So what I'm doing here is I'm using a tool called tsnode, which will be installed when you run the npm install. And what tsnode is, or what it does is, it takes a TypeScript file, converts it, compiles it down into JavaScript, and then it runs that JavaScript on whatever installation of Node that you have on your machine. Okay, so it's kind of a two-step process. It does the compilation and the execution. It doesn't show you the raw JavaScript that it generated. If you want to see the raw JavaScript, I'll show you how to do that in a moment. So if I hit return, okay, so these are the various console logs that my file is producing. So that's how you run a TypeScript file as a kind of a one-step process. If you want to see the actual JavaScript compiled equivalent of your TypeScript, which you rarely would in fairness, only in very extreme cases. So the way you do that is use a different utility called TSC, presumably for TypeScript compile. And so let's hit return. And if you look up here, here's my TypeScript file that we've been stepping through. Here's the JavaScript file that was just generated by the command that I submitted. And it has just raw JavaScript. None of the type syntax has followed through. If you look at the very first line, this postfix syntax here, that doesn't appear obviously in my JavaScript because it's not valid JavaScript syntax. Sorry, wrong one. Yeah. And, it's using kind of the old var rather than letter const. So that is the JavaScript equivalent. Now, if I want to run that, then I'm just back to using the node command because I have node installed. So if I now just go node, yeah, that's the one. That's the same output that I got when I ran the TS node. So TS node compiles and runs your code in one go. TSC, that utility, just generates the JavaScript output, which you can then run if you wish using the node command. Not sure what brought me onto that. Let's go back to our TypeScript. Oh yeah, type aliasing was what we were talking about. Okay, so just some more examples. So I'm declaring a data structure using type aliasing called course. I could have used, you can mix and match type aliases and interface data types. The compiler doesn't care about that, so I'm just consistently using type aliasing in this illustration here. So I've defined a data type called course. I've defined a type here called academic entity, and I'm saying an academic entity type is either a CAO student or a course. CAO student we defined that earlier on using the interface data type syntax if you go back up in the file. So here's where type aliasing kind of can shine. I've defined a more generic type called academic entity, and it can be a that or a that. Then I have a variable whose type is academic entity, and it looks like just, well, I'm assigning it student X, and student X was a variable that I declared earlier on, and it was of type CAO student. So that assignment statement from a syntax point of view is fine from the compiler's perspective. Just for illustration purposes, I've got a function here called process entity, terrible name for a function, and it's passed one parameter of type academic entity. Now, clearly, that means that within the body of this function, I do need to determine, well, is this parameter a CAO student or is it a course? Because presumably the logic that's going on inside here will be slightly different for one or the other. Yeah. So you will need to check within your code, and that's what I'm actually doing here. If we looked at the two structures, CAO student and course, we'd see that course has a property called code in it, which you can see right there, whereas CAO student doesn't. And this in operator, that's just a JavaScript operator. The in operator allows you to determine if a particular property is part of a variable. And so it looks like essentially what I'm checking here is to see, was the parameter passed into me, was it a, or is it a CAO student or a course? And I do some processing based on one or the other. The detail isn't important. Moving on. Okay, so I'm calling process entity with student X, and then I'm calling process entity with what looks like a course structure. Okay, there will be more on type aliases a little bit later on because it has some other features as well which can be useful. Type inferencing. This is goes back to the comment that Bernard Eich made about what he liked about the TypeScript language was the fact that TypeScript supports this notion of type inferencing. And essentially what type inferencing means is that you as the developer, in many cases, you don't have to be explicit about the type for a variable. The compiler will work out what its type is, or it will infer a type on your variable, essentially based on the value that you're assigning to it. Yeah. And that means then that we can omit the postfix syntax in lots of our code and let the compiler take care of inferring the type. So there's less physical keyboard typing that we have to do. And so as a developer, your performance kind of improves, your coding performance improves. And really what I often say to students is, as a beginner, you probably always are explicit about the types of your variables, but as you become more and more experienced, which admittedly you're not going to have time within this module, but as you become more and more experienced as a TypeScript programmer, you will find yourself leaning on type inferencing a lot more and let the compiler do the hard work for you. Every now and again, you may need to check to make sure that it is inferring the correct type, because it may not. So you need to check that maybe every now and again in more complex cases. But that's the essential point, right? And so to illustrate the simplest illustration of it, if we go right back to the beginning here, turns out, right, that, look, didn't really need to do this. I can take that out and let type inferencing work. How do we know? It's pretty obvious, but how do we know that the compiler has inferred the correct type? Well, you can check. Now, you can't see me, but there is a keyboard sequence called Command K, Command I. And so if I use that sequence here, Command K, Command I, it's telling me here what type the compiler is inferring for this variable. And it's making the right inference. It's inferring the string type on that variable. So that's something that you may need to use as you're writing when one is writing TypeScript code. That keyboard sequence, Command K, Command I, certainly within VS Code. I'm not sure if it's consistent across all editors, but just mouse over the variable, hit Command K, Command I, and then it tells you the inferred type. So I'm pretty much, most of the code that I've written here, I could have left out my postfix syntax. It would have worked it out for me. And so this screenshot is just illustrating what I've just shown you. And what I'm getting at down here is, it's actually, compiler is clever, surprise, surprise. It can make inferences that are not just, obviously it's very straightforward. That's a very straightforward inference to make, up here, but it works in more complex cases as well. So if we look at, let's get down to where I have slightly more elaborate examples. Okay, I'm not specifying here what type this variable is. But if you look at what's happening on the right, clearly the type for this variable is going to be a string. TypeScript doesn't have a char type, okay? And if I go Command K, Command I, yeah, it's saying its type is string. So it actually worked out, it looked at this method, it looked at the signature of the method, and the signature would have told it that this method returns a string, and so it inferred string onto that variable. Similarly here, we're accessing the length property of a string, so that hopefully would mean that this variable here is of type number. Yeah. Sorry, did I do the wrong one? Yeah, so it's getting number here. It's also telling me that I'm not actually using the variable, so it's kind of a useful piece of information, but you can worry about that now. And to take it even a little bit further, if you look at this line of code here, you might remember the map and filter functions from previous years. So here I've got an array of numbers. I'm calling the map method on my array, and I'm passing it in a callback. And based on what the callback is doing, the callback is doing a multiplication. So that must mean that the array that's being returned here is an array of numbers. In other words, this thing here, its type is an array of numbers based on the callback that I'm passing to map. I'm not being explicit about it, but again, if I do Command K, Command I, so I'm going to get it right this time. My keyboard skills are a bit clumsy. You can see here, it's worked out that it's an array of numbers. And there are some other examples as well where type inferencing is working, again, based on, or the examples are using map and filter, but you get the general idea. So really nice part of the language. Let's type inferencing. On functions, I've already mentioned it, but from a typing point of view, you need to also tell the compiler if it doesn't infer it. You need to tell it about the signature of your functions. We've seen this example already, I guess. So this is here's where you're specifying the type of the return value, and I'm doing it explicitly. And here I'm giving you an example where it works it out for you. It infers it. Let's just have a quick look at the file. So we're switching to a different file this time, I think. So that's okay. That's the example on the slide. And what's going on here now? Oh yeah, that's the inferencing. So, in this function here, I'm not specifying the return type here, but like before, if I use Command K, Command I on my function, it has worked out over here that the return type is number. It's inferred that for me. You'd be familiar with the arrow format of function declarations in JavaScript. Well, you have this arrow syntax in TypeScript as well, but from a typing perspective, here's how we specify the signature of an arrow function from a typing point of view. So this is my function name, and here's where all the typing information is. So again, it's saying in this case, and you put all of this before the arrow. Where's my arrow? There's the arrow there. So again, it's parameter types, it's return type. And again, I could have left that out because it would infer based on what's going on here. This is just another example. So I'm writing my own function here called rotate. The idea of this function is you pass it a string and you pass it what I'm calling an axis, and the function rotates the string around the axis if it finds it. And I'm saying here that the axis may be specified as a string. So in that case, it would look for the axis as a substring within the source string. Or I might pass a regular expression, in which case it will look for a particular pattern within the source string. And if it finds that pattern, it will rotate around the matching pattern. Now you can look at the body of the code yourself, although there's one thing I will highlight in it in a second. But in terms of understanding what the function does, I'm sure you already do, but I'm calling it, where do I call it? I call it here. So I pass the string ABC12 DEF, and I call it over here, and I'm passing it a regular expression. I'm saying look for the pattern of 2 consecutive digits within the string, which is going to be the 1, 2 in our case, and rotate it around that. In the second example, I'm passing it in this string here as my source, and I'm specifying the axis as an actual string. I'm saying look for that actual substring within it and rotate around that. And so if we just run it just for the heck of it. So that's where the rotate was used there, and it was also used here. Yeah, and there's just one piece of code in that rotate function, which you might think is TypeScript code, but it's not actually. It's just plain old JavaScript code. Where's my rotate? See this line here? The type of operator. Now you might think, oh, that's obviously a feature of TypeScript, but it's not. Type of is actually an operator that was available in the JavaScript language. And what it allows you to do is to determine whether a variable is either a primitive or an object or a function. That's all it allowed you to do, because primitives and objects and functions, they're all part of the JavaScript language. And so if you want to discover, is a particular variable, is it pointing at a primitive, or is it pointing at one of the other things, an object or a function? How can you determine that programmatically? Well, the type of operator in JavaScript allows you to do that. And that's really what I'm doing here. That's the only way I could, what I'm doing here obviously is I'm trying to work out, is the access parameter that was passed into me, is it a string or is it an object? Regular expressions would actually be implemented as an object behind the scenes. You probably have to know that about regular expressions in TypeScript, but I guess I Googled it to find out for sure. So that's all I'm doing here really, is I'm checking to see, is the access parameter that passed into me, is it an object? If it is, then I know it's a regular expression, and the kind of processing I'm doing here is based on the fact that it is a regular expression. The else here then is assuming that access is just a string and you're looking for a substring within the source string. So that's all that's going on there. So type of is not a TypeScript thing, it's a JavaScript feature. Other than that, really, there's nothing too sophisticated going on in the rotate function. It's just really kind of fairly standard JavaScript code in a way. That's a little bit about functions. I have kind of already made this point down here at the bottom, the second point in this. Oh, yeah. Yeah, I think I've already made that point. Like if you're not explicit about the return type, then the compiler will infer the return type of a function by simply looking at the return statements within your code. And that's how it does the inferencing. So that's all I'm illustrating here. And I think I've already showed it in the code as well, actually. Higher order functions. Higher order functions is not a feature of TypeScript, it's a feature of JavaScript. What is a higher order function? I'll stop talking for a while. What's a higher order function in JavaScript, in the JavaScript world? A higher order function is a function that takes as a parameter another function. Could have other parameters as well, but one of the parameters of a function is itself a function. And so we refer to the outer one as being a higher order function. Technically, a higher order function also covers the case where a function returns a function as its result. We don't see that often, but it is possible. So for the benefit of our discussion, higher order function is a function that takes a function as a parameter. Now, how do we specify the type for that function parameter from a syntax point of view? Because you have to tell the compiler these kind of things. And I'm illustrating it here. Now, the first example is a terrible example from a naming perspective, but just gets the point across. By the way, the function that we're passing in as a parameter, generically we refer to it as a callback, because presumably within the main function, it does invoke the callback within it. Otherwise, why would you be passing a function in as a parameter? Okay, here I've got a function which has a fairly useless function called print to console. And it looks like it takes two parameters. The first is a string. And here's where I'm passing a function as the second parameter. Now I've called the second parameter callback, which is a terrible name for a parameter. It's meaningless really. But here's the syntax of how I tell the compiler what type this parameter is. And so the way you interpret this, it's actually kind of using the arrow, that arrow function kind of syntax. Yeah. So it's saying that callback has to be a function. It's a function can only have one parameter of type string, and the function has to be one that returns a string. So whenever I invoke print to console, the second parameter that I pass to it, it has to be a function that honors this signature. Otherwise, the compiler will complain. Just as a by the way, in passing, sometimes this has got nothing to do with higher order functions now, but sometimes functions don't return anything. You know, they don't actually have a return statement. They do some logic, but they don't actually explicitly return a result. So from a typing perspective, we would say here that the return type is void. And indeed, the compiler would infer that if you didn't tell it anyway, but I'm being explicit here. And you can see in the body of my function, I don't actually have a return statement. And it doesn't matter really what I'm doing in the body of the function. Really, the point I want to illustrate is how we specify the type for a callback. So you've seen it here. This example, yeah, let's switch over to VS Code. So that's the one we've looked at. That's okay. Here I'm invoking it, and I'm passing it a string, which is fine, and I'm passing it a function. Okay, I'm inlining the function, but if we look at the, sorry, here's the function over here, beg your pardon. Oh yeah, so here's the callback that I'm passing into it. And if you look at the code that I've just highlighted, its signature is right. It's expecting only one parameter of type string, and based on what it's returning a string as well, because the two uppercase returns a string, and so my overall callback is returning a string. So this here is honoring what I've said it should honor up here. Let's get it to not honor that, just to show you what I'm trying to get across here. Supposing my callback, my actual callback that I'm passing in, returns the length of the string. So I go dot length. Now clearly, because I've got my squiggly lines, my callback parameter-wise it's okay, but it's returning a number, and that's not consistent with what the signature of the function that are acceptable is. And so that's why I'm getting my kind of squiggly line here. And if I open up my problems tab, although it's not crystal clear, sometimes the errors are easy to understand, sometimes they're not. So it's saying that the argument, that is the callback argument, it's the actual argument that you're passing to my function, that's its type, but that's not assignable to the type that it should be. The type that it should be is string and string here. So that's kind of what the error message is telling us. You're violating the types of the parameters that are being passed to my print to console function. Sorry, part of the file. So let's undo all of that. Same stuff is going on here. If I uncomment that, you get the same kind of error message. What else is going on? Okay, here's kind of a nice example as well. I've got a function called array mutator, and I guess from the name, what it suggests is this function, you pass it an array and you pass it a mutator function, a function that will change the elements in the source array, and it'll return the result. That's the intent of this array mutator custom function of mine. And the array that you pass into it has to be an array of numbers. And the second argument here, which is our callback, but now it's kind of got a nice meaningful name. I'm calling it the mutate argument. And the mutate argument has to be a function that honors this signature here. And you can see what's happening in the body of the function. It's mapping over my source array, if you like, and it's calling my mutator function. Yeah, so anytime I invoke array mutate, the second parameter, the mutate parameter, has to be a function that honors this signature. And then that's what I'm doing down here. For example, I'm calling my array mutator and passing an array of numbers. And here's my mutate function. And the mutate function looks like it's just 10xing every element of my source array. So this invocation of array mutator is fine from a typing perspective. Here's another example. Here I'm just declaring a function on the fly. Okay, I'm calling it selective decrementer, and it's a function that takes a number, and it looks like it returns a number as well. It's checking to see whether the number is greater than 10. If it is, it decrements it by 10%, otherwise it leaves it alone. But either way, the overall return value is a number. So this selective decrementer is also a function that takes a single parameter of type number and it returns a number. So that would be a valid mutator. And that's what I'm doing here, I think. I'm calling it with my selective decrementer. So syntactically, that's all good as well. And do I have an example? You know, if I just did this, for example, check out all of that. Now, the name now is not sensible, obviously, but my question to you is, what's the return type of this function here?
Boolean.
Boolean, yeah. So it's a valid function. Okay, it takes an integer, returns a Boolean. But if I pass that, doesn't like it because it's not respecting the signature that it should have, or that's acceptable. So that's why I'm getting the squiggly line here. And the compiler is doing all of that for me, which is great. Anything else interesting here? Oh, yeah. I'll just wrap up on this point, though we're running a bit late, though, I suppose. But what point oh yeah. Okay, this is fine here, right? But let's suppose in the function, had 5 arguments and a return value. Writing all of that code there, and if you were using that signature in a number of places, okay, you cut and paste it, I suppose, but it's just syntactically, it's quite loud, as we say. Well, to make it a little bit quieter, you could use type aliasing. And that's what I'm doing down here. I'm declaring a type called mutator function. And this type is defining the signature for a function. Yeah. And that now means that I can actually use this type as I'm doing it here. So I've got a new implementation of my array mutator called array mutator 2. But the second argument, from a syntax point of view, it's a little bit cleaner and arguably more readable. So often when you're writing code so that other people, when they read it, can make sense of it. Okay, and by using good names, that helps, I guess. So just using array mutator there because it's a type built in, a custom type that you defined. Syntactically, I would argue it's a little bit better than writing it kind of longhand as I did up here. So that's another use case for type aliases. Okay, we're done for today, I think. I'll pause just in case there are any questions specific to what I've been covering or more generally. No, okay, thanks for hanging on if you are still there. And I will touch base with you next week. I might keep an eye on Slack just in case I need to communicate with you between now and then. Thanks a lot. Bye-bye.
Thanks, David.